The following 3D object is composed of identical cubes. The volume of each cube is 27 cubic centimeters. What is the total surface area of the 3D object shown above? This actually looks like a really fun problem. Let's organize the information we have first. We're told that this 3D object is composed of identical cubes. So let me draw one of those cubes here on the side. Now, what do we know about this cube? Well, first of all, when you have a cube, all the dimensions are the same, meaning the length, the width, and the height are all the same measurement. And so I'm going to denote that by putting x, x, and x. That means the length, the width, and the height are all the same measurement. What else do I know about each of these particular cubes? Well, the volume for each of these cubes is 27 cubic centimeters. 27 cubic centimeters. And how do we get the volume of a cube? Well, we take the length times the width times the height, but specifically because this is a cube, we're going to take x times x times x, which we know is x to the third power, right? Do you see what to do here? So far, so good. Now, x to the third power represents the volume. X times x times x. But that's equivalent to 27 because we're told that in the problem. So what does this tell us? This tells us exactly what each side of this cube has to be, right? It's the number which when we take it times itself 3 times gives us 27. Or in other words, it's the number which when we cube itself gives us 27. Can you think of a number which when you multiply it times itself 3 times gives you 27? What number would that be? It's got to be the same number for each side, right? Yep, I think I got it. I think if we let x equal 3, and then we put that on each side of our cube, we get a cube with volume 27. Let's check. 3 by 3 by 3 centimeters. Okay, so if each of these is 3 centimeters and we multiply 3 times 3, which gives us 9. 9 times 3 gives us 27. Perfect. We now know that the side for each of these cubes is 3 centimeters. And that completes our first step. We need to know how big each cube is, right? How big is each cube, or the dimensions. So the dimensions for all of the cubes in this figure are 3 centimeters. 3 centimeters, 3 centimeters, and this is true for all of these cubes, right? So we could label that throughout our problem. But that gives us a big, good starting point. So now we're ready to move on to our second task, which is we're trying to calculate the total surface area for this object. Now, what's the surface area? It's the area of all of the sides of this shape, the top, the bottom, and all the sides. Now, what are all those things composed of? Well, notice they're actually composed of squares, right? On the top, I have a square. Do you see this square right here? And that square is 3 by 3. But we know that every cube is the same, and so that means this square, and this square, and this square, and this square also are going to be squares, and I'll just write it down. Each of these are squares that are 3 by 3. They're just squares, right? And the area for a square, so the area for a square is what? The area for a square is length times width or side times side, right? So the area for each square is going to be 3 times 3, right? If you want to think of it this way, length times width or side times side, or simply 9 square units, but we're talking about centimeters here. So the area for each square is 9 square centimeters. All right, now we're getting somewhere, right? So each square that is a face on this 3D object is going to be 9 square centimeters. Our last task then is to count how many faces are on this shape. So how many total faces? Or if we like, how many total squares are we talking about? Well, let's start counting. On the top, we have 1, 2, 3, 4, 5. So on top, we have 5 squares. So 5 on top squares. Because of symmetry, we also have to have 5 on the bottom, correct? So now we have 5 on the bottom. But now let's get tricky. Now let's talk about the sides. The sides are these gray darker spaces. So here's a side, and then there's a side on the other side of this cube, right? And then that's true all the way around. But let's be smart about it. So we have one side here, 2 sides, and then that other side that we can't see is going to be 3 sides, right? So 1, 2, and then the other side makes 3. So I just want to write down 3 sides. This is true for all of these cubes on the outside. That's going to be true for this other cube over here. So that guy over here is going to have 3 sides as well. Same thing over here on this one. 1, 2, 3 sides. So he has 3 sides that we have to count. And this last one, 1, 2, he has 3 sides as well. That cube in the middle doesn't have any exposed surface area except the top and the bottom. He gets counted for top and bottom, but he does not get counted for all the sides. That means that the total number of squares that I have to count for this 3D shape is as follows. 5 plus 5, which is 10, plus 3 plus 3 plus 3 plus 3, which is 12. So that's going to give us a total of 22 squares. Or in other words, squares, not sides. Sorry. There's 22 squares that we're counting. So we have a total of 22 squares, 5 on the top, 5 on the bottom, and then if we count around the edge, around the outside, we should get 12 additional ones. So that's going to give us 22 total. We're so close to the finish line. We're now ready to put all of that information together, right? We know that each square is 9 centimeters. We also know that we have 22 squares that we have to count. So to get the surface area, the area of all of the squares on the outside of this figure, that means we have to take 22 and multiply it times 9. I'm going to do it really fast here just by hand. And 22 times 9 is 198. That means our answer is going to be 198 square centimeters makes up the surface area for this 3D object. Now that used a little bit of thinking, but it was not too bad when you break it down. Start with your volume and use that to help you determine the length of each side of the cubes. And from there, you can find the area for each square and then count the total number of squares for the object. If you have any questions at all, please don't hesitate to reach out.